Welcome to Calc Chats 31. Today we're going to be talking about Taylor and Maclaurin series. These are a special type of power series. And yesterday, the last time we met, we kind of discovered that we could write the function of 1 over 1 minus x as an infinite sum of all these polynomials. So 1 plus x squared. And so basically when I added all these polynomials, I got back to my function 1 over 1 minus x. And so with Taylor and Maclaurin series, we're able to construct multiple series that can represent different functions. So sine, e to the x, ln, we're able to find all these different functions by constantly adding up terms of polynomials. And we use those in infinite series, which we call the Taylor and Maclaurin series. So to kind of give you an idea of what I'm talking about, so we have this thing called a Maclaurin series, and basically we need f to be any given function that is differentiable throughout all orders. So it's continuously differentiable. And then we create what we call a Taylor series at x equals 0. So we're just focused on x equals 0. And this Taylor series, we take f of 0 plus the first derivative of f of 0 times x plus the second derivative of f of 0 times x squared divided by 2 factorial plus the third derivative times x cubed divided by 3 factorial. And basically what we're going to end up with as we take these derivatives and divide them by n factorial and multiply them by x to the n, we're going to get a series that represents our function. So like I said, we're going to be dealing with e to the x, sine of x, ln of x, and these series are going to help us learn a little bit more about how those specific functions behave. So this is called a Maclaurin series, and the important part of the Maclaurin series is the x equals 0. So we're only focused at x equals 0. And we call the partial sum is denoted as Pn of x. So that's sub n. If we were talking about P4 of x, that would be the polynomial of order 4 if we had n equals 4. And that basically just means is we have the first, when we plug in 1, 2, 3, and 4 to here, that's the polynomial we get back. And so that's kind of what we're going to be looking at today, is constructing these series with the Maclaurin series. We also have what's called the Taylor series, and this is kind of the broad idea. Maclaurin is one subset, but Taylor is a little bit more broad. Same thing, we need a differentiable function, and this is at x equals a. So Maclaurin is x equals 0, Taylor series is x equals a. And again, when I take that function, I take that derivative, and I keep summing up those terms, I'm going to get a series that is really, really close to that function. If we go down here, again, this is kind of the same thing as before, but with Taylor. This is our partial sum, and we call this the Taylor polynomial, again, of order n. So we're going to be talking kind of how to create these polynomials, and we're also going to be looking at some polynomials that we have to know on the AP exam, and it's going to make life a little bit easier for us moving forward. So before we dive into these examples, I just kind of want to show you what's going on. So we know that we're summing up the derivatives and then x to the powers to guesstimate these, well, not guesstimate, to get a very good accurate series for this function. And so if I look at the green, this is my series sine of x. Or sorry, this is my function sine of x. When I'm using the Taylor series to approximate sine of x, and let's say I just took the first term of the series, so I only added one term, we can see that it's just a straight line. That red line, that would be just like saying, okay, x. Order 3, we're adding 3 different polynomials, and we see the blue, it kind of dips down and starts to get this kind of curly Q shape to it. Order 5, again, we see the purple. It's beginning to look a little bit more like sine. We have a little bit more wavelengths. We're adding 5 polynomials. Order 7, we're looking pretty darn close. And then by order 9, we are almost there. We have almost all the kind of ridges that sine of x has. And so these polynomials give us a really good idea of how these functions behave. And so that's kind of, I just want to bring this up because that's kind of the point of these polynomials. It's really cool because we can do different things when we take all those terms and sum them up, and we can do things that we weren't able to do with those regular functions with Taylor polynomials. So this first example asked me to find the Taylor series generated by the function e of x at x equals 2. And so again, if we look back, this is a Taylor series because it's x equals 2. And so I take f of a plus f prime of a times x minus a plus f double prime of a x minus a squared over 2. And so I'm just going to kind of write out the first couple terms. And if we notice about e to the x, e to the x is a series that f of 2 is equal to e to the x, f prime of 2, or sorry, f of 2 equals e to the 2. F prime of 2 is also e squared. And we keep going. And so the derivatives are all the same. So that's kind of really easy for us. We don't have to do much solving for the derivatives, since the derivative of e to the x is the same. And so when I'm writing down this series, I can just plug in my derivatives. So f of 2 is e to the 2 plus f prime of 2, e to the 2 times x minus 2 plus f double prime of 2 is e to the 2 times x minus 2 squared all over 2 factorial. And as I keep going, I notice that I can make a general term for my Taylor polynomial. So I can say that the sum from n equals 0 to infinity of e to the 2 over n factorial times x minus 2 to the n. And again, this goes back to our Taylor polynomial. And in this case, it's really nice because all of our derivatives are the same. So this example is asking me to find the third order Taylor polynomial of this function, 2x cubed minus 3x squared plus 4x minus 5 at x equals 1. So third order, that's P3, and that means I need to find the third, up to the third derivative. So I need to find f of 1, f prime of 1, f double prime of 1, and f triple prime of 1. So f of 1, that's just 2 times 1 cubed minus 3 times 1 squared plus 4 times 1 minus 5. That gets us negative 2. Our f prime of 1, now this derivative goes to 6 x squared, so we take 6 times 1 squared minus 6 times 1 plus 4. Again, I'm just taking the derivative and then plugging in 1, and we should get 4. F double prime, when we take the derivative again, get 12 times 1 minus 6 equals 6, and then f triple prime is just 12. So these are my derivatives, and now I can just simply plug them into a Taylor polynomial. So again, we take, in this particular polynomial, we say that f of x equals f of a plus f prime of a, x minus a plus f double prime of a over 2 factorial times x minus a squared plus f triple prime of a over 3 factorial x minus a cubed. And so all I'm going to do is I'm going to plug in my derivatives and my A's. And so I just went ahead and paused it and wrote down all of my derivatives and my A's within my formula. So we should get -2 plus 4 times x minus 1 plus 6 over 2 factorial times x minus 1 squared plus 12 over 3 factorial over x, or times x minus 1 cubed. So that is our third order Taylor polynomial. So these are series that you have no choice. Being an AP Calculus BC, you have to memorize these series. And so you can kind of memorize the first few terms, but what's going to help you really is the ultimate, just the series. So I'm going to have a printout available for you guys, but if you'd like to copy these down and kind of start getting them in your brain, start sleeping on them, memorizing them, eating them for breakfast, whatever you have to do to make sure that you have these down and memorized. So again, take the minute to copy them down, or if you want to, just wait until class. So this is a really great DIY problem for you guys to try. So it just asks you to construct the first 3 non-zero terms and the general term of the Maclaurin series given. So we know, going back to the previous slide, that sine of x is this series right down here. So really similar to our power series, instead of sine x, I just would like you to try to construct sine of 2x. So go ahead, pause the video, take a minute, try to figure it out if you can. So all we're really doing is plugging in 2x instead of x, and this is the general term, and these are the first 3 terms of the series. So here are your ABC problems to try. So A, find the Taylor series generated by the function 1 over 1 plus x. We have that on the previous slide. B, find the Taylor polynomial of order 3 generated by x cubed minus 2x plus 4 at x equals 0. And then third, we're given that f is a function that has derivatives of all orders. F of 0 is 4, f prime of 0 is 5, f double prime of 0 is -8, and f triple prime of 0 is 6. It asks you to write the third order Taylor polynomial for f at x equals 0 and use it to approximate f of 0.2. So go ahead, pause these videos, try them. I'm going to put the answers on the next slide. Well, it'll be in a few seconds for you guys. But go ahead, pause, try them yourself, see where you are, and then make sure to write down any questions that you have about these problems. So here are your answers to the ABC problems. Number B was actually easier than A. So if you didn't get A, go back and I guess try B. I flip-flopped them for you guys. And then C, you got your answers down here. So go ahead, please make sure you note any questions that you have. Thank you for watching this video, and please be sure to like and subscribe.